All right, hello everyone. Welcome back to Data Programming 1. Today we're going to be talking about creating functions. But first, let me remind everyone that I'm going to be live streaming my lectures Monday, Wednesday, Friday at 8 a.m. Come join us on Blackboard Collaborate. You can ask questions in the chat. I'll be there answering them. We've gotten about 20 people on average over the last couple, so I'm going to keep doing it. You guys are welcome to come join us. If you're looking for a little incentive to make sure you keep up, having a scheduled opportunity to watch the lecture might be just the little push you need. All right, so let's go ahead and get started. I'm going to take the camera off and jump right into this. All right, so today we're going to be learning about creating our own functions. We'll be learning about function syntax, including just the basic structure, how we have to write the code so that it works, well, how to look at input and output to our functions. They take parameters. We'll have three different kinds of parameters or arguments. Whether they print something or just return something, whether they actually compute something for us or they just do something. And then we'll trace through some examples. While we're on this page, please continue to read chapter 3 of Downey's book. We started that last time. And also under today on the schedule, there's a link to another article called Creating Fruitful Functions. So definitely go ahead and read that one out also. All right, I know I keep coming back to this robot code, but I like this as an example for functions. Our robot just wasn't very smart. It had the power to move one step forward, and that was it. To make it move more steps and be able to have a little control over how far it moved, we have this special block of code, the move code. This is our function. This is an example of a function that does something. It's not producing a value like maybe a math function would, but instead it's actually doing something. It's moving the robot, printing a value, something like that. So we'll have two different kinds of functions. Functions that do something, maybe they print something, they may change some variables, or they may produce a value, like a math function. We saw an example of that last time when we had the f of x. So we might say a math function computes something and returns a value. Downey calls these fruitful functions. He's the only person I've ever heard use that word. Okay? Everyone else just says that they return a value. So be aware of that if you use that outside of the context of this class. And there are even functions that do both of those. So I want to start out with something you guys may be a little more familiar with, the math functions. In math, we would have a function something like here, f of x is equal to x squared. I want to talk about exactly how we would turn this into Python code. And the example is right here. And I want to walk through all the different pieces and show you how they do match up. So first up, we need that function name. Okay, in math, it's going to be f. We've got it right there. First thing we see. In Python, the function name is f. Also, the next thing we need are the parameters. In this case, the math function takes x. We need an x here, and the x goes inside those parentheses. Then, in Python, we need to tell it it's a function. In math, we just use the equals, and we've got a function. But in Python, we need to tell Python that we are defining a function. So we're going to be using the keyword def, D-E-F, followed by the name of the function. We also need that colon there. The colon is more or less the same thing as the equals in math. It's telling Python that all the stuff that follows is going to be part of this function. It's all the steps that we need to do, to operations to simplify, whatever, to get to do what we want the function to do. All right, and then in math, we have the right-hand side. This is what's going to be evaluated and returned when we call this function. In Python, we actually need to explicitly state that this is what we're returning. We may have a function that does a bunch of other stuff. Maybe it's printing out debugging code. So we need to actually say this is what we want to return. And we may have more than one line. So note that all of the statements inside the body of the function are indented. And this is how we tell Python that these are the statements that go inside the function. All right. Python is really uncaring about most spaces. I can put a whole bunch of spaces if I want between the X and the stars, or I could not have any spaces there. But it is extremely picky about the indentations for functions. So make sure you've got 4 spaces here every time you do this, or however many you're using. It's got to be the same amount of spaces. All right. Let's take a look at one more function here. So in math, I'm computing the area of a circle from a radius, so pi r squared. So to do that in Python, I'm going to have all these pieces. I still need the name of the function, g. I'm going to need the radius that goes inside the parentheses. I need those parentheses to say that this is the function list of parameters. I need the colon. That's going to be the same as the equals sign right there. I need that keyword def. And then I have to tab over all the statements. I have to tell Python exactly what I want to return because I could have multiple steps here. And then I need whatever I'm going to be returning. In Python, we have to write out the value for pi unless we import it from math. We'll be talking about that later today. And then we need to explicitly multiply and explicitly use the exponent double star. All right, now we may have this version uses a longer word radius. Frequently in programming, we'll have much longer but easier to read, simpler versions that do things. We use more variables. In math, it's very concise, often very difficult to read, but very short. In programming, we'll see that we tend to break things down into more steps, and so it's important to have variables that are very descriptive. So we'll often use whole words for variable names, like write out the word radius. We also may have more than one step. In this case, instead of using the radius, I'm starting with the diameter, and in order to compute the radius from the diameter, I'm going to add a second step here to just divide the diameter by 2, and then that will give me the radius. All the lines of code that belong to a particular function body are going to be indented with those 4 spaces. All right, so next up, I want to do some demos. We're going to go and we're going to take some built-in functions so we can explore their behavior, just things that are already in Python, see what they do, see what they look like, and then we are going to write our own versions of these functions just to go through these steps and get some practice. All right, so next up, I'm going to pull up PowerShell. I'm going to go to my directory where I'm doing all my work. So that's going to be documents, CS220. Now if I look here, I've got some folders. I'm going to make another directory for lecture 6. That's today. We'll move into that. And then we'll just pull up Jupyter Notebook. And there it is. All right, so the first thing I'm going to do is just go over here to new and open up a new Python 3 notebook. I'm going to save this as main, very common name for pretty much all things programming. Go ahead and save that, and then, hope this is not deceptive, I want you guys to just completely ignore this magic. Okay, I'm going to copy and paste in some code. This is an HTML window. When I execute this, it's going to make this white box wider. And that's going to let me use more of the screen so I can show you better what's going on. Let's start out with this ABS function. ABS, we'll give it a -3 and just see what it does. Shift enter to run that, gives us a +3. ABS, +3. What does that do? +3. Okay, so you may have guessed from the name that ABS is actually short for absolute value. That's going to take any input that's negative and multiply by -1 to make it positive. And anything that's positive, it's just going to retain as that positive version. Okay, so if we're going to write our own version of this, we're going to need some pieces. First, we're going to need a name for the function. I'm going to be a little more explicit. I'm programming. I'm going to use the entire word absolute value so I know what I'm doing. It's going to take one parameter. I'm going to give that an X. I need to use the keyword def so that I'm telling Python that I am now defining a function. And I need to end that with a colon, just like my equals. When I push enter here, Jupyter Notebook is really smart. It knows that I'm defining a function. It's already tabbed over one spot for me. All right, now we don't have conditionals yet. We'll be working on those really soon. So right now I'm just going to use some mathematical trickery. So to take a negative number and make it a positive number, one of the things I can do is square it, because a negative number times a negative number is always a positive number. So I can use x squared. And then what I can do is I can take the square root of that. The square root function will return a positive value. So I can just raise this to the 0.5 power. And now this is going to be the absolute value. So I've squared it. That'll take the negative sign, make it go away. Square root returns the original number. Last thing I need to do is tell Python that I want to return this value. Okay? When I shift enter, it tells Python to store this function somewhere, remember where it is. And now I can start calling it. I could say absolute value, and then I can give it -3 again. Run this cell. It's going to return 3.0. One of the differences here, that a built-in ABS function returned an integer, In my version, when I started doing the square roots and exponents, returns a floating point value. I'm okay with that. Let's test it with the positive numbers, make sure it works. Absolute value, positive 3, run that, and again we get a positive 3.0. All right, let's take a look at the next example. I want to do square root. So that's SQRT. Let's give it the square root of 25. We should get 5 back, right? Shift Enter will run that. And I instantly run into a problem. So Python has built-in functions, and then it's got things that are installed with packages that I need to import. And square root is one of those functions that's in the math module. So I'll need to bring in that module. And a module is just a collection of functions. So let's go ahead and do that. The keyword to, or the command to bring that in is going to be from math import sqrt, square root. When I run that with Shift Enter, now I should be able to do square root of 25, and it should work just fine. It's going to return the floating point number, 5.0. Okay, so if I want to use something else from that package, like pi is a member of that package, I want to just print out pi. It's going to give me a name error here. So I could do from math import pi, run this, and then when I type pi, it knows that it's a variable that's been assigned that value. Now, I don't want to have to do this for every single thing, every time I want to use a little bit of math. So there's another shortcut. Oops. Fingers on right keys. I can just import star, and that star will grab everything from math. Shift Enter will run that, and now we've got access to all of the functions in math. We'll talk a little bit later about how to explore the math package and see what functions are actually there. But for right now, I want to take a look at writing my own version of square root. So again, if I'm writing a function, I'm going to get into the keyword def to tell Python I'm defining a function. I'm a programmer, so I'm going to go ahead and use a long variable name, or a long name for the function, square root, with the underscore between it. It takes, let's see, just one parameter. I'm going to call it x because I'm doing some math. And then the colon there is just like my equals. So that's 1, 2, 3, 4 parts. All right. Next up, I'm going to be computing the square root. Python has a really gorgeous built-in exponentiation function. I just raised this to the half power and we are good to go. Last thing, my function needs to return this so I can actually do something with it, not just compute it and forget it. When I run Shift Enter, Python is now going to remember that square root is in cell 14. When it needs that, it's going to come back there. So now I can start exploring this. Square root, and we'll give it 25 again. We'll run this, gives us 5.0. Perfect. Let's try negative 25. Let's try and break this. One of my favorite things to do. It turns out that in Python, it actually has like the built-in capability to work with imaginary numbers. So when we take the square root of 25, we do get an imaginary number. So for those of you guys in math who find yourselves using a lot of Python someday, it's a very powerful language. So right now we're just taking this variable because it's the last line of these cells. It's just being put into the outbox. If I were to store this in a variable instead, we'll call this just s equals square root of 25, and we run this cell. It doesn't actually print anything out. I need to go back and print s like this, and then I get the value. Or I'm going to copy this. And in Python, in Jupyter Notebook and the command line intermediate mode, I can just type s, and if it's the only thing on that line, it's just going to print out the value. So I can do that again like that. And it's up to us how we want to use our functions, whether we want to store them in variables, print them, or use them in other expressions. The next one I want to do is pow. It's going to raise a number to a power. This function takes 2 arguments. So I could say take 2 raised to the third power. When I run that, it should give me 8. 2 times 2 times 2 is going to be 8. All right, so now to write my own version of this, I'm going to call this function power. So I don't want to reuse the same name because that will deny me access to the one in math. It takes 2 parameters. So, and of course, as a programmer, I can choose longer words. I'm going to go with base and exponent, but I'm going to shorten up exponent a little bit. All right, I need to end this with a colon, just like my equals, and I need def to tell Python that this is a function. All right, and push enter. It gives me that automatic tab over. This function is going to be returning a value. All the math ones are going to do that. And this will just be base raised to exp. I know it's a little silly writing this one. It's already built into the Python as an operator, but it's a good demonstration, I think. So I'm going to go ahead and shift enter this. And in fact, just to be clear, with Jupyter Notebook, I can define a function and I can use it right here in the same cell. There's nothing preventing me from doing that. But a lot of times programmers will like to write all of their functions and put them up near the top of the Jupyter Notebook, and then keep their work organized a little better. In this case, just to demonstrate this, I can use my function right here. I can take 2 raised to the 3rd power, calling this function, and run that, and it defines the function and runs it all in one cell. So totally possible to mix these up. So this is a function with 2 parameters. It's not too difficult to keep track of them, but it's possible we may have functions with many, many parameters. And I don't want to have to go back and look up the order they go in every single time. So one of the things I can do is call the function with the, so as it is right now, the 2 will go into base, the 3 will go into exp. They're called positional parameters. They just assign, match them up. First one goes in the first parameter. Second argument goes in second parameter. But if I want to, I can actually explicitly say that the base is going to be 2 and exponent is going to be 3. And when I run this, Python now knows exactly where I want to put this 2. And I did put them in the same order, but I don't have to. Let me move this around. There we go. When I run this, it still matches them up. 3 went into the exponent spot and 2 went into the base. All right, so these are known as keyword arguments, where I'm explicitly stating the name of the variable, the parameter, inside of the power function and telling it what I want it to be. We saw this last time when we used the print statement with sep and end. Those are keyword parameters. Important to note that keyword parameters always come after the positional in the list. Positional arguments always come first, and then the keyword parameters. All right, and once we have keyword parameters, they can come in any order we want. They'll get matched up correctly. All right, and finally, keyword parameters are often confused with default parameters. So I want to just do a quick demonstration of a default parameter. So I'm going to go ahead, grab my function. I'm going to make a new copy down here. And what I'm going to do is say, what if I really use my power function to square things, like all the time? That's the most useful thing in the world. So I'm just going to give it a default argument that says, if nothing is specified for exp, we're just going to use 2. All right? And then when I run this, I can call the function power. I can give it a base of 4. This is a positional argument, so it's going to go in that first spot there. There's nothing for exp, for the exponent. So it's going to just default to the 2. So if I run this, it's gone ahead and said 4 squared. If I were to put in, I could put in the 2 if I wanted to and run that. Still going to give me 16. If I put in 3, it's going to say, okay, I put in a positional argument. Just ignore the default one. I don't need it. So I can do that. I get 64. I can even specify that the keyword argument here, exp equals 3, should give me 64 again. All right, and I just want to stress one last time that the positional ones need to come first. And we'll go ahead and we'll do this the wrong way. exp equals 3, and then we'll put the 4 in. So we'll put the positional argument after a keyword argument. When I run this, it's going to give me a syntax error. And just let me know that positional arguments need to come after the keyword arguments. It's very clear. All right, so just a little bit more about the rules for filling in parameters. Python gives us a lot more options than a lot of other programming languages do. So I just want to make really clear how all 3 of these work and they fit together. So take a look at this example function right here. Def foo. So in programming, foo and bar are frequently used as names of functions when we're just talking about a generic function that doesn't actually do anything. In this case, this function takes 2 variables, x and y. And the y here is given a default argument. Default, I can see the little equals right there. Now, what I want you guys to do is when you see a function, the first line of the function is the one that we'll be executing first, this definition, and it's going to tell us we have an x and a y. And these are exactly like assignments, variable assignments. So it's the same thing as though I'm saying x equals, and then whatever x is getting, it's coming from the outside of this function. Same deal with y. Y is getting something from outside the function, or if we don't specify something, it's getting this -1. These aren't actually part of the code. It doesn't show us this, but you can imagine it as though the first two lines were x equals and y equals, or x gets and y gets, if you like that language better. And that's going to happen when we call the function. So we have to define it first so that Python knows where to go when I call foo. And in this case, I'm calling it with 99 and 100. So these are positional arguments. The 99 will match up to the first parameter, the x. So it's the same thing as saying x gets 99. And then the second parameter, a second argument, 100 goes in the second parameter, y. So we don't use the -1. We'll instead use this 100. And y will get the value 100. I made a slide for this and forgot about it. So the 99 goes where the x is. The 100 goes into y. First parameter to first argument to first parameter, second argument to second parameter. Okay, another way that we can call this function is by using keyword arguments. I've got them here in order of priority. So position, top priority. Keyword is second. So the moment I run into a keyword argument, and Python knows this because when I'm calling the function foo, I can see right here that I'm using the name of a parameter and equals and giving it a value. So the equals is the clue to Python that this is a keyword argument. It tells it we were done assigning positional arguments and now we're on a keyword. So the y here is going to map to the one that's actually the parameter y. And then when we have x, it'll map to the parameter x. And finally, if I don't have enough arguments, if I never specify the y parameter here, so in this case I have 99, it's a positional argument, there's no equals, it's going to go in the first position where x is. And then I've got this closed parentheses, I am done. So Python's going to go and look at the rest of this line right here to see that it needs to use the value -1 for y. Let's head over to the worksheet and get a little bit of practice. Alright, so I just jumped over to our web page. Here's the worksheet I'm talking about. We're on Wednesday, September 16th. I'm going to go ahead and grab the Word document one so I can write on it during the course of the lecture. Let me just go ahead and pull this up and scroll down to the first problem. Alright, I'm back. Got the worksheet pulled up. So I'm going to start right here. At the very top is this reminder. Positional arguments number 1. Keyword arguments number 2. Default arguments, third choice. Alright. And so we're going to be looking at this function right here. It just has two parameters. This one just adds two numbers together. But as far as the worksheet goes, the add part is not important. We're just looking at calling this function. So let's just take a look at, let's just start with problem 1. So take a look at this, guys. Do you think, so the goal here is we want to either identify what value will go in x, what value will go in y, and decide whether it crashes or not. So I'll go through, I'll do the first one. So x here, I have my 3. That 3 is the first parameter. It's going to go into x. So I'm going to just stick a 3 right there. Then I'm going to notice that I'm out of arguments. There are no default arguments, so there's nothing here for y. So this is going to crash. Let's put a big ol' X right there. All right, let's take a look at number 2. So if we put the very first position, it's going to go into x. So we'll put a 3 right there. The second position is going to go into that position. Second argument goes into second parameter. So y is equal to 4. And this is going to be just fine. This will run. All right, let's take a look at number 3 now. What if I switch them around? Is this still going to work? So the first argument will go in the first parameter, x. So in this case, it'll be 4. And the second parameter will go in second argument will go in the second parameter. And that'll be 3. So this should work just fine too. I've got exactly the right number of arguments. Python will be happy. All right, this one. Let's take a look at number 4. What do you guys think will happen? So the first position will go into the first parameter. Second position will go into the second parameter. Move that over so they're lined up. That looks good. But then I've got an extra parameter. Python will not be happy with that. So this is going to crash. Definitely. All right, let's take a look at this. Let's skip down and take a look at number 6. The best way for you guys to use this worksheet is probably to come back later, when you're studying for the exam, which is in about 2.5 weeks, or studying for the quiz on Monday, is to come back to this worksheet, grab a blank copy, and run these guys in Python Tutor. Watching me do them on a video is probably the least efficient way to learn this stuff, but to do it yourself, you will learn more. So let's take a look at this one, number 6. The first positional argument is going to go in the first parameter up here. So x will get the value 7. Am I on the right line? Yep. And then it's telling me that x is equal to 6. There is a problem right here. X has already been assigned the value 7. Python knows that. And at that moment right there, crash. All right, same deal with number 7. We're going to put the 7 and the 8 in first. So we'll have 7, oops, I missed, and 8. And then it gets here and says x is equal to 9. X already has a value. That's a big old crash. All right. These last two look good to me. We're just going straight to the keyword. So it's going to take a 10 and put it in the x position, 11 for y. That should be just fine. Same deal if I switch the order. Python does not care. It's just got to fill everything in. So it'll put a 10 in y, an 11 in x. And as soon as everything's all filled in, Python's happy. So that'll be fine also. All right, at this point, if you're watching at home, pause the video, go try number 10 through 18, and then come back, and I'll go through a couple of them. You can check your work. If you're watching the live stream version, I'm not going to pause. We're just going to go right through. All right, let's take a look at number 10 first. So this has absolutely no arguments whatsoever. So the next thing we're going to do is go to default arguments. For t, it's going to be assigned the value 1. End is going to be assigned the nothing. There we go. And it's going to crash because there is nothing assigned to the parameter word. So that's going to be crash. All right. If we actually assign the word, so this is the first positional argument. So word is going to get the value ha. Just like that. Then we're done. So we need to go to keyword, no keywords. Default will be next. So t is going to equal 1. And end will be the empty quotes. And everything is happy. We've got all 3 filled in. It's good. All right, let's take a look at 12. Again, we're going to put ha in the first spot. So this is going to go right here. T is going to get the value 2. So at this point, we're done with positional arguments because I see that equals. So we're on to keyword. So T is going to be assigned 2. And then we're done. So we need to go up to default arguments next. And end is going to be assigned the double quotes. There we go. I wonder why my quotes are different. Oh well, no worries. Then on number 13, this one's a good one. So in this case, we've got ha. That's going to be assigned right here to word. No problem. It's the first position. So we'll just pop that down right there. Then the next one is a keyword. End is equal to the exclamation point. I'm going to just copy and paste so the quotes are fine. That's fine. And then we need to go to default arguments because we're out of arguments here. And we see that t does have a default argument of 1. So I'm just going to copy that, paste it right there. And again, this one will also be fine. No problems because all of the arguments are filled in. All right, next up. So we go straight to keyword arguments. We assign t the value 2. Word gets yo. And then, so here t gets 2. We fill that one in first. The word is equal to yo. Get rid of that. Get rid of that. There we go, just like that. And then we have to go with this default value for end. And everything is filled in. Everything is happy. Nothing was used more than once. Okay, so check this out. Assign W right here to word. No problems with that. I don't think I grabbed the copy. Still didn't get it. There we go. All right. W right there. Then we have 3. 3 goes into T. Check that out. And then EB goes into the final one, end. Just like that. Okay. Again, everything is happy. It all looks good. Let's see here. This one, T is equal to 3. So we put a 3 right there. We're down to, so this is keywords. There's no positional arguments. Then we're on to default. So we've got the double quotes here for end. This one's going to crash though, because we never assigned a value to word. There's no default for that one, so this is a big old crash. All right. This one, let's see what we got here. This one's going to crash too, I can tell right away. So we're going to put a W into word. It's the first position. Then we're going to write, so at this point we are on to keyword arguments. That means we are done with positional based arguments. So end is going to get the period. So quote, period, quote, done. And then this 3 here is going to say, whoa, it's not a keyword anymore. Keywords always go at the end, that we're done with positional arguments. The moment Python sees that, we're going to crash. And then this one's obviously going to crash. Do we have too many arguments? One question mark and an exclamation point. Too many, it's going to crash. The will go into word, the 1 will go into T, the question mark into end. And at that point, it knows that there are too many and it crashes. I'm just going to put an X right here. All right, I do want to spend a little bit of time talking about modules. You may have noticed on the slides from the previous lecture that there were a couple of slides at the very end about modules. I didn't get to those. That lecture was 5 minutes too long anyway, so I've moved that to here in this lecture. So modules are just collections of functions. And they come from packages. So packages come from a number of places. Some of them are built-in. These modules, like the built-in modules, contain like the input function we talked about, print, length, etc. We also talked about some of the, like, I'm going to call them pre-installed. We saw an example of that with math. We had the square root, sine, cosine, pi, a lot of that kind of stuff in those. Some of them we had to install ourselves. So when we used pip install Jupyter or pip install matplotlib or those other things that we started with the like how to install Python video, we had to install those modules. And then we can also write our very own modules. Those would be custom modules. I've got a demonstration here. We're going to go take a look at a pre-built dog module that the team wrote, and then we'll write our own cat module. So head over to the website and then go ahead and click on the code right here. What we want to do is grab the dog.py. So I'm going to left click on that. I'm going to right click raw and then save link as. And I want to put this in the same directory where I have been working. So this is lecture 5. I need to go to lecture 6. I'm going to save this right here. All right, now when I go back over to look at my Jupyter notebook, I can see that I have dog right here. First thing I'm going to do, I'm just going to go ahead and double click this and open it up and take a look at what's here. We see that there are 2 functions. The first one, speak, and the second one is fetch. All right, so those are things that dogs can do. Let's see here. Let me head back over to Jupyter Notebook. I'm just going to rearrange my windows so they're side by side. Next thing I'm going to do is we're going to need to bring these functions into the Jupyter Notebook, into Python. Because this is a separate module, it's in a dog.py file. So to do that, all we need to do is from dog import, we'll grab everything. That'll bring in both functions. So shift enter to run that. And now we can use the functions that are available in dog. So we can use the speak function. I need to put the parentheses in to make it call the function. Shift enter will run that. We can see this dog bark, 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 as dogs do. I can do the other one too. So test this out, fetch. We run this with shift enter. The dog brings us a stick. So next thing, we can also, I want to just highlight one thing. There are functions that do things and functions that like return things. And we can store those values. Let's see, I'm going to use RV to store the return value. Oh, there's 2 functions. Let's go RV1 equals speak. So we'll just grab whatever the return value is here and run this. And run this. There we go. We see that it still barks. Bark, 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 bark. Let's go to the other one now. RV2 equals fetch. Shift enter to run that. Now check this out. The first time we ran fetch, it returned a stick. Stuck it right there in the out box. This time, it didn't do anything. It turns out that we have actually stuck the value stick in RV2. So if I just put that in there and run it, Jupyter Notebook will print out the value of the last thing. And this is the only thing, so it is also last. So it's in the outbox right there. I can also just print this. And I would need to do this if it were not the last line. So there we go, printed stick. Now, let's take a look at RV1. So I'm going to do RV1. nothing. All right, let's try and print this. Run that. It's actually printing out none. So none is a special value in Python. It tells us this is the absence of a value. When we have a function that doesn't return anything, so return none right here, it actually specifically says it's not returning anything. I don't actually need to put this in. If I were to delete this line, and we'll save this. There it is, file, save, done. Then we'll go back over here. We need to rerun the import because I made a change. So I'm going to shift enter that. And then I'm just going to rerun I'm going to rerun everything. Kernel, restart, run all the cells. There we go. We can see that, oh, there's a bug because I didn't change this one. Time out, let me get this all fixed. All right, just commented out the one with the bug. Let's see if this works now. So I want kernel, restart, run all. Okay, there we go. We can see this still works, even though I took out the implicit, or the explicit return none. It automatically adds that every time we have a function that doesn't return anything. It just means that it didn't return anything. All right, so next up, when we write functions, we have a choice a lot of times about what we want the function to do. It's up to us to implement it. And a lot of times we need to produce a value that will print to the screen. And we've got choices. We can either have the function, in this case, we call the function with some code, we give it arguments, the function does its stuff, arguments are put into parameters, and when we return something, we return a value. And that lets the user decide whether they want to print it out. Another option would be the function could print out whatever happens. In this case, this arrow down at the bottom indicates that we've returned something, and then the function is printing it. So we can call print either inside the function or outside of the function. In this case, in this example, suppose I wanted to print a series of numbers. So I could send those numbers to the function. The function could print them out 1, 2, 3, 4 on the terminal, and that could be ended. Another option would be, what if I wanted to use those numbers for something else? So I call a function, it computes some numbers for me, and I'm going to send them back to the user. That user then could do whatever it wants. Maybe it wants to make a bar graph or add them together. So by returning the value and letting the user do the printing, it makes our program a little more versatile. It gives the user more control. So it's almost always better to have it return the value rather than print the value itself. So compute something and return the value, and then the user can print it out as they see fit, or they can do something else with it. One final thought on the printing versus returning issue. We only get one chance to return. There is only one answer. Maybe you're familiar with this show, Who Wants to Be a Millionaire? In that show, Regis always asks the candidates, is that your final answer? And when they say yes, final answer, they don't get to change it anymore. There's no second choice. They don't get to go back and give them a different answer. So let's pop over to Python Tutor and do a quick example of this. So I'm back over to our webpage. Under Tools, we have Python Tutor. I'm just going to click that right here and jump over. I really prefer the live programming mode. I mean, really, why wait when you could just see what's happening? So the first thing, I'm just going to go ahead and define a function. We'll do countdown and need parentheses and a colon. So remember, I need the keyword def, the name of the function, parentheses with my parameters inside, and a colon. It's a lot like the equals. This function is just going to print some stuff out. Print 3, print 2, print 1, and then that'll be the end of it. So let's go ahead and call the function and just sort of walk through and see what happens. All right, so I'm going to go back to the first, and then I'm going to click next to walk through this. So the first thing Python does is it says this line right here and just makes note of the function countdown is on line 1. Just remembers where it is. And that's all that's going on here in this global frame. Then when we get to next, it calls the function, and we jump up here into the function. That wasn't next, that was last. All right, hold on. First, next, next. Then we jump into the function. This line right here says assign all of the parameters. There aren't any, so it's done with that line. Then we're going to print 3. There it is. Print 2. There it is. Print 1. All right, excellent. It says that it's on the last line. The return value is none. That's going to get put back over here. If we had a variable like x equals, then that variable, the value none would be assigned to it. I'm not doing anything with it, so the none is just going to be ignored as soon as I click next, and then it's finished. All right, I'm going to make a little change right here. Instead, I'm going to, we'll print countdown, whatever the value is there. And then instead of printing these guys, we're going to return 3, return 2, return 1. All right, so let's start at the beginning first. All right, that first thing it does is remembers that countdown is on line 1. Then when we call the function right here on line 6, it goes in and says, okay, assign all the parameters. There aren't any. After that, it's going to go to this line 2 where it returns 3. All right, there it is. The return value is 3. So it's going to plop that down and replace it right here. It's like basically simplifying this part of the code right here and putting a 3 in. So it hops down here, prints out the 3, and then it's done. It never actually gets to these 2 return statements. The moment it hits a return, it's done with the rest of the function. This is actually known as dead code because it can never be reached. Never will we see this executed because it will always get to this return value first. All right, next up, I want to talk about creating our own modules. And our dog needs a friend or an enemy. So I'm going to go ahead and use a new file, but this time I want a text file. And the first thing I'm going to do is I'm going to go ahead and name my text file. And I'm going to name it cat.py. So modules are named with the extension py. And then I can just click OK. There we go. We've got this thing here. I'm going to just pause and rearrange my windows so we can see everything. All right. Now I've got the windows arranged. So I've got cat over here, dogs down here, and my Jupyter notebooks over here. So I'm going to go ahead and start giving the cat some functions. And just like dogs, cats can also speak. So we'll give it a speak function. Def, name of the function, parentheses, and a colon. All right, so we'll just print out, cats aren't that loud. We'll just give them subtle, tiny meow. And that should do it. So I need to go up here to Menu, File, Save. Close that up so we can still see everything. Over in here, I need to import my new cat. So let's go ahead and do that. Import. All right, I'm doing this wrong. I'm doing it wrong. From cat. Import star. There we go. That's the right order. My brain cramped up for a second there. Okay, I'll run that with Shift Enter, and now we have the cat there. So now we should be able to type speak, and we'll get the cat speaking. There it is. It says meow. All right. The problem with this is I just lost the dog. Check it out. Speak is always going to be the cat. Doesn't matter how many times I do this. I'm never getting the dog back. I have replaced that function, the dog speak right here, this one, with the cat version. So Python has just overwritten it. The fetch should still be good though. So if I do fetch, run that function is still available. If I want the dog back, the dog barking, I need to import, or from dog, import star. And now, fingers on the wrong keys, speak should be the dog. But now the cat is gone. So if I want to get around this, because both functions have the same name, I need to import them a little bit differently. So in this case, to preserve both functions, we'll do import dog and import cat. Now when I do this, I've imported the modules, it's got the list of functions, but I didn't just import the functions that from dog import, that says go get the actual functions, bring these in. When I just import dog and cat, I've imported the entire package, the module. And to call the functions from within the module, I need to actually specify which one I want. So I need to say dog dot speak. And then Shift Enter will actually bring up the dog speaking. From the cat, I need to say, I'm using the cat module now, cat dot speak. And that will bring up the cat's version. But now both of them are available. I just need to tell Python a little bit more information about which module I want to bring these functions in from. All right, and as we're learning more about Python, we've introduced a new type. We've got modules here. I just brought in a cat module. And one of the best things to do every time we do this is to explore with type. So I'm going to run this with Shift Enter. What I see is it tells me that it is a module. I can do the same thing with cat. Type cat. Shift Enter, again, a module. I believe I can do the same thing with speak without the parentheses, and that should tell me it's a function. So I've got all kinds of things I can do to learn about Python. And another one of those things, there's a command built into Python called dir. It stands for directory, but I can go ahead and do that for a module. This is going to list all of the functions available in that module. There's a bunch of stuff here. There's anything beginning with the double underscore we can pretty much ignore. Built-ins, cache, doc file, all the way down. And we can see here that it actually has two functions, fetch and speak. We'll talk about some of these later on, but for right now, this is just a way to grab that list of functions. Let's take a look at the functions available in math. I can do the same thing, dir math, or I could Google this. I forgot to import it, so we'll just do import math. Got that. Now we can do dir math, run that. There we go. And this is going to be a long list of all the functions available in math. A whole bunch of them. And again, all those special variables beginning with double underscores that we can ignore. All right, let's just pick one out. Let's take a look at ceil, C-E-I-L. This stands for ceiling. It's going to round up. So it's going to take any floating point number and round up to the nearest integer, but always rounding up. So some things we can do, let's type math.ceil without the parentheses. Let's just see what this gives us. Okay, it tells us that this is a function, and this is because this is the last line of a Jupyter Notebook line. Otherwise, we'd have to print this out. All right, so it's a function, math.ceil. It takes one parameter, x. All right, next up, let's try and get a little more information about this. Always type math.ceil. There we go. And this tells me it's a built-in function or method. Awesome. But to figure out what it really does, we need some documentation about it. There's a way to get that, so I can type math.ceil dot, and then one of those special variables that we were just talking about with the double underscore doc. This is the documentation for this function. So if we do shift enter on that, it tells us exactly what this is doing. It returns the ceiling of x as an integral. This is the smallest integer greater than or equal to x. Let's just try this out now. Math.ceil, and we'll give it a 2.3. There we go. So this should be the integer 3, the largest integer, smallest integer greater than that number. I was just looking at this output for a second. It's got these like \n. It's kind of awkward to read. This is the programmer version of a string. Instead, it might be better to actually print this out where we get the user version. So again, that was math.ceil dot underscore underscore doc underscore underscore. And shift enter on that. There we go. Returns the ceiling of x as an integral. I think they mean integer. At least that's the language I would have chosen. This is the smallest integer greater than or equal to x. There we go. Now it looks good. Let's go ahead and try this same thing with our new cat function. So let's see here. We have print cat dot speak dot underscore underscore doc underscore underscore. Run that, and we find that it's none. We have not actually provided any documentation for the speak function for the cat. To do that, all I need to do is go, and for the first line of the function, I can just add a string, and that string will be the documentation. When Python imports this module, it's going to take this special variable, underscore underscore doc, and give it the value of whatever I put in this string. So I'm going to say this function makes the cat meow. And the quote there. And now I need to save this again. So file, save. And now I'm going to need to re-import this because we need to re-bring it into Jupyter Notebook. So import cat. And now I'm just going to go ahead and copy and paste this function one more time. But I screwed up somehow. Timeout. What did I do wrong? All right, I got it working. Here's what I had to do. I needed to go back to menu, kernel, restart and run all. That was the secret. As soon as I did that, close that up. It now is giving me this documentation string, and it prints it out. The cat. This function makes the cat say meow, just like I told you it would. You're going to run into little things like that with Jupyter Notebook where something will not work that you think it should, and the answer is restart and run all. All right, so second to last thing I want to do today is go through one more of these worksheet problems, and then I want to introduce the interactive exercises. So first up, this is number 21 from the back of the worksheet. Just going through this and trying to decide what is Python going to print out. A valuable exercise to be able to read code And coming up, a lot of the exam questions and quiz questions are not about writing code, but they're about understanding what code is really doing. So in this case, as we walk through this, I've got my starting arrow there pointing at number 1. There we go. So the first thing Python's going to do is say that, okay, function C is defined on line 1. I'm just going to remember that. The next thing it's going to do, it's going to jump down, and it's going to skip over all of the contents of function C. Gets to line 4 and says, okay, now I need to remember where function B is defined, right there on line 4. It's going to skip over all the content of function B. It doesn't need it right now. And then go down and say, okay, on line 9, I'm defining function A. I need to remember where function A is. It's going to skip all of that stuff and go down and execute function A. That's the next thing it's going to do. All right, so it's going to jump up into function A right there. See that we don't have any parameters. Then it's going to go print out A1. All right, so I just grabbed a little box and wrote down A1 so I can remember what's printed. All right, next thing we're going to do, it's going to go down and call function B. Okay, I'm going to leave this arrow right here, and I'm going to grab another arrow and move it up to function B. Because when we're done with function B, it's going to return to right here. All right, but it jumps up to function B next. It looks at the parentheses, sees there's no parameters, and moves down. From here, it's going to print out B1. So let me just quick add a B1 over there. From then, it's going to keep going one line at a time in order and call function C. All right, so let me grab another arrow. It's going to jump up to function C. Check out no parameters. So it's going to print out a C. Whoops, hold on, Mike. A little crazy there. There we go. Prints out the letter C. After that, it's reached the end of this function, so it's going to return. And it's going to go back to where it came from. It was function C was called right here on line 6. So then this arrow is going to advance to line 7. And it's going to print B2. So let me go ahead and grab a B2, put that in. From there, we've reached the end of the function. So this is I'm going to delete this arrow, and it's going to jump back to where function B was called from in line 11. Then finally, it's going to move to the next line there and print out A2. All right. Let me pull up those interactive exercises and just introduce them to you guys. All right, so I'm back over at the web page for today. Right here are the interactive exercises. I'm just going to click on that. It's going to go ahead and log me in. I've got my name up here, so I can keep track of my progress and use this for participation or whatever we choose to in the future. Right now, this tool is still under construction. It's pretty good. It's in a shape that I'm willing to share with you guys. So here's the idea. It's based on that Python tutor I've been using for my demonstrations, but it's got a little more, it's designed to help guide you guys through the learning process. So I'm kind of excited about this. If we just take a look at one of these, the idea is we're going to click on the line and it's going to tell us what's going to be executed next. A little glitch right here. It looks like I should be clicking the first line, but it's going to be what's executed after the line with the red arrow. That's the current line. So what happens next is it's going to go remember where foo is. So that's the first line I need to click. Then it's going to skip down. Print is going to be the next line. And this just kind of walks us through things. Then it's going to call foo. So we jump up into function foo. And then the next line to be executed was that print B. And here's one of those examples where a question pops up. It blurs the text to like give me a clue that I need to go do something else. I need to put down that it's going to print a B. Then I'm going to check this. Cool. That's the end of this function. So the next line to be executed after the red arrow, line 6 is where it was called from. So I don't need to click line 6. I need to click line 7. There we go. And that's going to be the next thing to be printed. So after this is executed, it will print that D. And then it's going to ask me which function is being called. Foo. And that's all I need to type. I don't need those parentheses. Got that right. So then it's going to go back up into the function foo. I need to click on the def line because that's where the parameters would be initialized, but this doesn't have any. Next thing it's going to do is print out that B, and then it's going to return to that very last line, and I see program terminated. So that's what tells me that this is correct. All right, that's going to be it for today. Have a great day, everybody.